Welcome to today's lesson on building a robust tenant lifecycle management system. In the world of SaaS and cloud platforms, effectively managing customer lifecycles is paramount. It's about more than just adding new users. It's about orchestrating their entire journey from onboarding to offboarding, ensuring security, isolation, and efficiency. By the end of this session, you will be able to understand the core concepts of multi-tenancy and why robust lifecycle management is crucial. You'll also be able to identify the critical states a tenant moves through, from provisioning to archival. We'll then grasp the key architectural components that enable this orchestration, and finally, explore practical implementation strategies that can make your systems resilient and scalable. Let's dive in. At its heart, tenant lifecycle orchestration addresses a fundamental challenge in multi-tenant systems. How do you safely add and remove customers without impacting others? Imagine a major search engine or a large social network. Each new enterprise client, each new region demands isolated resources, specific configurations, and a clean exit when they depart. This lifecycle isn't static. It involves 5 critical states: provisioning, where resources are set up; active, for normal operation; suspended, for temporary halts; deprovisioning, when cleanup begins; and archived, where data is retained but inactive. The secret to success, as seen in platforms managing thousands of changes daily, lies in automated workflows. These workflows eliminate manual errors and maintain strict isolation guarantees throughout every transition. Now let's deconstruct the architecture that makes this orchestration possible. Central to it all is the tenant orchestrator. Think of it as the brain, a state machine that coordinates provisioning across multiple services, triggering parallel workflows for database setup, API key generation, and resource allocation. The resource provisioner then steps in, handling infrastructure allocation. It creates isolated namespaces, dedicated processing queues, and network policies, ensuring each tenant gets guaranteed resources while remaining completely isolated. Next, the configuration manager applies tenant-specific settings, from log retention periods to processing rules, all automated based on service tier. The security boundary engine is crucial, setting up authentication tokens, access control lists, and encryption keys to prevent data leakage. Finally, the cleanup orchestrator handles offboarding, systematically removing data while respecting vital retention policies, even for legal compliance. So, how do we implement such a sophisticated system in practice? A powerful strategy is event-driven orchestration. Each lifecycle operation publishes events that trigger downstream services. This loose coupling makes your system incredibly scalable and fault-tolerant, allowing services to react independently. For maximum isolation and performance predictability, consider using dedicated database schemas. Rather than shared tables with tenant IDs, each tenant gets their own schema objects, significantly enhancing data separation. Integrating with an API gateway automatically configures unique routing rules and rate limits for new tenants, providing tailored access without manual overhead. Critically, the orchestrator should implement compensating transactions. If an onboarding step fails, it automatically reverses completed actions, ensuring your system remains consistent and prevents partial, corrupted states. This rollback mechanism is key to reliability. We've covered a lot today, exploring the intricacies of building a robust tenant lifecycle management system. Let's quickly recap our key takeaways. You now understand that a successful system achieves automated onboarding in minutes, ensuring new tenants are provisioned swiftly and efficiently. It guarantees complete resource and security isolation, preventing cross-tenant data access and ensuring data integrity. We also discussed the importance of graceful offboarding, where data is archived according to retention policies, leaving no trace while complying with regulations. And finally, you've seen how robust state management with compensating transactions provides essential error recovery, keeping your system consistent and reliable. As a self-assessment, consider this. How would you design a rollback mechanism for a failed tenant upgrade operation, ensuring no data loss and system stability. Reflect on the principles we've discussed.